Okay, welcome to the study hall for May 7th. We got some data sufficiencies where there's a particular focus on setting goals. What's interesting here is that it's really, really interesting. We'll talk about the origins of this as the class proceeds. If you've seen a few of my workshops before, you'll kind of know where that part of the discussion is headed. But a lot of the time, even after months and months of studying, people are still doing data sufficiency problems without any real goal. You know, they're just kind of like pushing stuff around and hoping that something cool happens. So, in other words, this is a problem shared by people who are brand new to this and people who have been doing it forever. So, talk about it. Here's the copyright notice again. These are all from the free GMAT prep software. That's the only GMAT prep software that we can actually use, the one you have to not pay for. So please keep that in mind when you submit. Okay, let's do one. Try that. By the way, if there is anyone who doesn't know the answer choices for data sufficiency, you can put that. Hopefully that's not the case, because in order to understand the discussion today, you're going to need a pretty solid foundation in how data sufficiency works on the fundamental level. But if anybody does need that, I can put the choices on the board. Okay, give this one a shot. Okay, we should probably be wrapping this one up decently soon. So that we'll discuss that as we go. Comment is interesting because it seems to imply that something is inherently hard about technical cases, but that shouldn't necessarily be true. If you don't have an answer to this, go ahead and pick one. If you have to guess, you shouldn't feel terribly bad about having to guess, by the way, because here's the current profile of responses. Like, notice that basically this is pretty much random. So if you are one of these non-responders, you should pick something. You should pick a thing. That is a thing. Okay. All right, well, let's take a look at it. It seems like people who are guessing are all guessing D. Interesting, because here's the profile now. Like, basically everyone should guess in the last minute or so is guessing D. It's not D, anyway, whatever, let's just talk about it. So, okay, well, you have data sufficiency questions. There's a couple things to understand about this. The first is that questions are either yes, no, or they are like find this quantity type of thing. So this is the yes, no variety of questions. So, okay. By the way, going back to that graphic that we had on the cover for a second, the first page of the study hall. I mean, this is kind of a cute quote, but it's actually the point here. I mean, a lot of people just don't have goals that they can articulate, especially when it comes to the yes-no, like data sufficiency situation. You know, if you cannot tell whether you have reached your goal, or if you can't articulate why you have reached it, then you probably don't really have a goal. I mean, let's go back to this one and let's talk about this. Because with yes-no questions, the point is, I know a lot of people in this audience are actually software programmers, but even if you are not actually a software programmer, you can still probably think on the level of what you would have to put in if you were like programming software to do things. So like here's the question. How would you program software to tell whether not sufficient or sufficient has been reached in this problem? This is not a completely general question. This is this specific problem. Like you don't have to program the software to actually do the work. Like you don't have to tell it how to pick cases or how to manipulate algebra or whatever, because that's, you know, fraud. But how would you program that? I mean, this is a simple question, but a lot of people cannot answer it. Because in this question, no, this has nothing to do with certain values at all. Nope. Not certain values. That has nothing to do with that question. I mean, somewhat courageous to be the first responder there, but no, certain values have absolutely nothing to do with this question at all. Nope, it's not a thing here. All right, now we're getting warmer. Okay. This is, let me take these two responses, and like one of them is, they're still not totally entirely what you want, but they are very close. Okay, but let me tell you what the problem is still. Problem is that these are not really things. Neither are these. Do you understand what I mean by that? I mean, I know what you mean, but see, the problem is, and make sure that you guys understand what I'm talking about here. The problem is that these are not goals that are directly actionable. Okay, and if you were programming an actual computer, you could not use words like yes and no or true or false because the computer doesn't know what those are. You know, the same thing is these are not goals that are directly actionable. No, they're not. Meaning, I mean, what I mean by this in the most plain way possible is that you, same thing with prove and disprove, it's still not concrete enough for a computer, right? But the point is you can't do math and have the words yes and no pop out. That's not a thing. So what this means is if you are thinking in terms of the words yes and no, then you are automatically adding complexity to this problem that does not need to be there. Like, same thing, you can't do math and have the words true and or false emerge. Also not a thing. So what you do is you have to go one more step to this. You want to translate these into specifics, and then you never want to deal with this silly, vague words again. So, I mean, what does a yes actually mean to this question? I mean, it not being too smart about it. A yes means that x to the fourth plus y to the fourth is actually greater than z to the fourth. So, that's what it means. X to the fourth plus y to the fourth is actually greater than z to the fourth. And then there's this no. No means no. It means x to the fourth plus y to the fourth is not greater than z to the fourth, which means it's equal to or less than. And here's the point. The point is that you should ditch the words yes and no forever and ever from this point onward because they are not things. See, these are actually things. You can actually try to do these things. You can actually do math with the goal of making these things happen. Okay, this seems like a small point, but it's not a small point. It's not a small point. You know, like these are quantitative goals. If you programmed a computer to do this, you could actually tell the computer, hey man, if this stuff is greater than this stuff for at least one case, and then it is less than or equal to for at least one case, then that's not sufficient. And if both of these are not reached, then that's sufficient. So this is the point. The first step of every single yes-no question is to translate the words yes and no into the specifics of the question, and then ditch the words yes and no forever. Do not think about them at all after that point. So there it is. And there's also a device that because I mean the same thing, like as long as you know what not sufficient means, because the computer doesn't know what not sufficient means. Like if you're programming a computer, we still have the same issue again. So let's take that from the previous page and let's make a device. So if you've seen enough of these workshops, you've seen me make this device before. But what you can do, what you should do, is make this device where you take those two possibilities, just make them into two rows of an organizational device. And then you make columns for statement 1, for statement 2, and for both if necessary. And then you put check marks in these things. So statement 1, statement 2, and then if you have to combine them, which you may or may not have to do. So if you make this device every single time you have a yes-no question, you will know exactly what your goal is. That's the point. So just do it. Like step 1, whenever you encounter a yes-no data sufficiency question, make this thing. That thing. Just make it. It's a thing. Notice that these are translations of these. And then the point is that if you can make the situation happen, make a situation happen, then put a check mark in the appropriate box. If not, then, and then if you can get 2 check marks in a column, that's not sufficient. And then notice if you fail to get 2 check marks in a column, then that's sufficient. Okay, so sufficient is actually not really a goal here. If you can't get both check marks in a particular column, then that's sufficient. So notice this is what you're trying to do. The thing that you are actually trying to accomplish here is that. In other words, this is your actual concrete goal. That's what you're trying to do. I mean, this is just a fundamental definition of what sufficient and not sufficient mean. You know, if you can make both, if these are both possible, then that's what not sufficient is. And if they are not, then that's what sufficient is. So because notice the difference, right? You can't really try for sufficient on these problems. You can't do it. You can't try to fail to make things happen. You can only try to make things happen, and then you might fail. So this is what you're actually trying to do with every single one of these items. All right, now let's do it. So notice we have goals. Right, this is the thing we're trying to do. I mean, there's 2 advantages of setting this up, by the way. The first is, because again, the big problem with these problems is that no one knows what they're even doing in the first place. That sounds kind of silly, but I think you can see what I'm talking about there. People are just kind of randomly pushing stuff around and hoping that it means things. But, you know, it's like monkeys typing on typewriters to a certain extent. But the first advantage that this confers on you is that it's actually a thing. It's something to do, which sounds stupid, but like people freeze at the beginning of these and they're like, oh, I don't know what to do here. And this will totally obliterate that. I mean, you can't freeze and have nothing to do if you have this to do. And then the other thing is it will remind you of goals. I mean, if you just look at this, it's right there. Okay, these are the two things I'm trying to do. There they are. Those are the two things I'm trying to do. You can't forget what you're doing halfway through. So, all right, let's take a look at statement 2. Probably look at that first, because it looks like it's not as involved as statement 1. So let's try this first. Because notice the device lets you start either way, right? You have to do the statement 1 column and the statement 2 column. Now notice with data sufficiency, you've seen me put this thing on the board before. There are basically 2 ways to approach a data sufficiency problem in general. I mean, you've got your textbook methods, including algebra and whatnot, and then you've also got specific cases. Long story short, if you try doing this algebraically, it's not really going to work because there's no easy relationship between x plus y and this. And we don't know the signs of these quantities either. I mean, so if you try to mess around with algebra, sooner or later you'll discover that you can't really determine the status of these. And in inequalities in general, you're going to find that happens a lot of the time. So this is how you're going to pretty much have to do this problem. Those are going to be cases, fractions, or whatever. Those are going to be part of the cases that you want to test, right? So you'll find that this is generally the most efficient way to approach inequalities. Okay, let's actually make a separate screen for these 2 questions here because, I mean, okay, if you guys, I mean, we'll see if anybody can tell me what I'm going to say in response to these because there are stock answers to these questions. You should make sure that you know what they are. I mean, does anybody know what my answer is to that? As here, if you've watched these workshops before, there are basically 2 secrets to success in life. And that's all you need to answer this question. Anybody know what I'm talking about? 2 secrets to success in life. No, that gets too much brain, too much thinking for Ron. Hard work's not really a thing of this test as much as people think it is. This is definitely a working smarter and not harder kind of test. But, okay, do you remember what my 2 secrets to success are? You've seen these videos before, you'll know what they are. Here's what they are. Do stuff, and don't not do stuff. There they are. I mean, this is not just the GMAT, this is secrets to success in life, too. I mean, do not sit there and wonder what you should do. I mean, don't do it. So the answer to this question is just do stuff. In other words, just try something. Just pick one and try it. And if you get stuck, stop. Done. End of. I mean, because therefore you will never ever run out of time if you can do this red thing. I mean, do not push variables around and hope that cool things are happening. If you do not know exactly what you are doing and exactly why, then don't do it. Like same thing here, in these problems you should not be doing anything at all until you understand what your goal is, which is I need to make this happen and then you turn around and make that happen. So, but don't try to front load too much of this decision-making stuff. Just pick a thing and try it. If it doesn't work, it'll become really clear, very plainly that it doesn't work. Like in this one, if you try algebra here, you'll raise these things to the 4th power, and then the first issue you'll have is you don't even know if you can do that because you don't know what happens to this alligator, to this inequality sign. So already you're stuck. But even if you don't realize that, you'll get x to the 4th plus y to the 4th plus a whole bunch of extra terms, and then you're still stuck. And boom, done. End of story. I guess that didn't work. So that's the answer to that. Just do things. If they don't work, throw them out, do other things. And then See, okay, now let me answer this one real quick because, you know, this is probably not what you meant by these words, but let me pick at these words. I don't like these words because here's what they imply. There. That's why. I mean, these words are like absolving yourself from responsibility, and that's not the point. I mean, this test doesn't have tricks on it. In fact, if you've watched enough of these workshops, you'll know what I'm talking about. But there are never any trick questions on this test, ever, 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 not even sort of. Like this last problem is a problem on which algebra plainly does not work. And there's not really like tricks to make you think that it does. It doesn't work. If you try to do it, you'll hit a wall pretty quickly. Yeah, I mean, basically we're just back to this again. But you just try stuff. Just throw things at it. I mean, the point of the test is not to fool you or to stick a foot out and try to trick you. But the point of the test is to be unpredictable. It's not the same thing as tricky, but it's unpredictable. I mean, you're not going to know what works every time. That's the point. You won't know ahead of time what will work or what won't. I mean, sometimes you will, but not all the time. And so the point is to just throw stuff at it. And to be very honest with yourself about I'm stuck, if that happens. That's the point. That's what you're doing there. Okay. So yeah, but just don't think in these terms because no, because then you think you have to be reactive and you think you have to like get into their brains and think from that standpoint. And that's not, you don't have to do that. You just have to kind of do what the problem says. So all right, let's talk about this problem. Let's do statement 2. So statement 2, we're going to have to test cases. Okay, if you've seen my workshops previously, you'll know this, but you can make columns. Whenever you test cases, you can make columns for that. So what we're going to do is we're going to have to pick x, y, and z. And then we're going to need to find x to the 4th plus y to the 4th. And then we're going to need to find z to the 4th. So there. And then subject to this constraint, right? So what it also helps you to do is just to actually write that on there. You should write down the things, and you should not write down the things. Because that way you don't have to keep this in mind. Like just when you put this on your paper, this is a very small thing to do, but it's small but powerful. Just make sure that you put that there. Just remind yourself. Okay. Someone give me an x, y, and z such that x plus y is greater than z. Now, your first case can be random. So, yeah, your first case is probably going to be something like, 10 and 10 and 0. Or even like 1 and 1 and 0, sure. I mean, honking that's probably not the first set of numbers that you pick, honking. That's probably the second set of numbers that you pick. You can let me know if I'm right about that. The first case of numbers is probably something like this. So, and then 1 plus 1 is greater than 0. Well, that's checked. So, okay, 1 plus 1, that's 2. And that's 1. That's a 1. That's supposed to be a 1. Okay, so 2 is greater than 1. So check mark here. Okay, notice if you make this device, you immediately understand exactly what the goal is. What is the goal now? Why 1? Why not? You mean these ones? Just kidding. I'm seeing whether you're paying attention. Thank you. You are paying attention. That was a test. I swear. I was just seeing whether you're paying attention. Yeah, 1 to the 4th is not 0. Yeah. Maybe you guys are typing to get a no just so that there's less typing in the box. But make sure that you are not thinking, do not think of the word no, do not think of the word yes, do not think of the word true, do not think of the word false. You are done with those words forever and ever and ever and ever and ever and ever. Okay, do not ever think about the words yes and no. This is not a joke. Your thought process should never contain those words ever, 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 at all, ever again, from the very moment that you make this box. Like, these words are gone. They are gone from your mind forever. You should only be thinking about these things. Don't think about yeses and nos. If you let the words yes and no enter your brain, you have just made this problem about 5 times as hard as it has to be. Because now you are not thinking about things that are things anymore. The goal is that. The goal is to make x to the 4th plus y to the 4th less than or equal to z to the 4th. Or conversely, to make z to the 4th bigger, which is probably a more intuitive way of thinking about it. So now, the goal is to make z to the 4th bigger than the left-hand side. And if you understand that that's the goal, it's not very hard to pick the values that will do it. So, I mean, you just got to think about how to do that. So while this is still true, like notice that if you have this all written out, you don't need to remember this stuff. But you want z to be, so like just look at what we've written down here. Right, here is this. And note in particular that part of it. So z needs to be small, whatever that means. That could mean large and negative, by the way. But we want this to happen. So what we need here is but z to the 4th should be, at least relatively speaking, big. So negatives are one very good way of accomplishing that. Yeah, so let's use Hunking's numbers. Let's use like 1 and 1 and minus 1,000 or whatever he said it was, she. That definitely works. I mean, 1 plus 1 is definitely greater than negative 1,000. And so then this is 1 plus 1 is still 2. And this is something really huge that is positive. So 2 is definitely less than or equal to plus big. In fact, it is very clearly less than that. So we have checked off this box, and statement 2 is not sufficient. Notice, by the way, that you can use these values too. But notice the other point is when you study this problem, that's less effective. So for when you review, using negative 1,000 or something like that is much more effective than using negative 2. Like in terms of getting you to understand what's going on or what matters. Because I mean, the problem with these values is they look random. I mean, I know they're not random and you're probably choosing them for good reasons. But the problem with them is that they look like they are just random numbers. And so when you go back and review the problem is you'll have to figure it out all over again. Whereas this is clearly not randomly chosen. Like there's an obvious point of picking a number like this, and that is, okay, well, it's very clearly less than whatever stuff, but if I raise it to an even power, then it gets huge. So just consider when you guys review these problems, consider like exaggerated values that really make these properties clear. So, because I mean, if these are random numbers, that's good. It's good that you're doing stuff and not doing stuff. But just in terms of rhetorical effectiveness, right? Okay, now let's take this to another page and let's do this. Let's go back to statement 1. Okay. There. So that's what we have so far. So far we have that statement 2 is not sufficient. Okay, let's make columns again for statement 1. All right, someone tell me what columns would you make here that would be most appropriate to make? You might need to make another set of columns that you didn't need for statement 2. Well, columns, like the columns are, that positives and negatives sound like the things that you put into the columns. But that's neither here nor there at the moment. I mean, the point is what are the headings? I mean, always organize before you put stuff in. I mean, like, okay, obviously we need to have a column for X, Y, and Z, right? That should be, I know obvious is a swear word, but we got to have that. Now, what else should we, again, between 0 and 1 later, those are the things you're going to put into columns. That's not the point right now. Not the point. The point is to make the columns. Like, what do we need to do? Like, think about what the thought process actually is in this problem. Like, when we come up with numbers, yeah, okay, what Suvik has is the point, right? You've got, you need to check that these things are true. Because this is not trivial. Like in the last one, you could just look at X plus Y and look at Z and make sure that this was true. Like, you didn't need separate columns for that. But what you should have here is you need to check that condition actually holds. So you should check that X squared plus Y squared is actually greater than Z squared. And that's supposed to be a question mark at the end. I'll fix that in a moment. So you're supposed to check that. You should make columns for that. Don't do it in your head. Really, don't. Do not do it. No, don't even think about it. Then once you have that, then you are ready to actually check the thing that is the question, which is this and this. You know, this question, I've answered this in many, many sessions before, so I'll just give you the quick rundown. The answer is maybe not, but that's fine. Because 2 minutes is an average. Yeah. I mean, I'm always amazed by the number of people who think that 2 minutes is a limit. I mean, guys, it's an average. Averages are not limits. I mean, there will be just as many problems over 2 minutes as under it. So, I mean, that's fine. Which isn't a deal. Because remember that time management has nothing to do with minutes and seconds anyway. It really has nothing to do with it. In fact, if you have to look at a clock at all, that means you have bad time management. Done. End of story. I said it. Like, good time management is if you know exactly what you are doing and exactly why you are doing it, you keep doing it. And if you don't, you stop. And if you kind of think you sort of know what you're doing, you stop. Mike, no, that's not true at all. Not even sort of. There is absolutely no correlation between difficulty and length. Not even kind of, sort of. Nope. In fact, in data sufficiency, the hardest problems, not that you'll know which ones those are anyway, are shorter on average. I mean, just go to your OG and look at how long the problems are at the end of the data sufficiency chapter versus the beginning. Like, you'll notice the problems at the end are actually shorter. So, nope, it's got nothing to do with that. It's also weird that everybody thinks that long is the same thing as hard. If you do think that long is the same thing as hard, let me tell you exactly what your problem is. It's that. It means you're trying to do too many things in your head. Because that's the only time that length makes any difference at all in terms of how hard a problem is. If you think that hard has any correlation at all to long, you're doing too much stuff in your head. And you're not writing enough down. There. End of story. Done. Okay, back to our regularly scheduled programming. And again, by the way, you know, there's a reason why I think so much about setting up devices and making columns and things like this. I mean, I've shared this with you guys in previous study halls, but my memory is in the first percentile of the human population. Actually, that's the lowest percentile. I actually had a head trauma when I was a kid that destroyed a lot of the part of my brain that does memory. So it's bad because it's bad. I can't go to the grocery store for 3 items without writing them down. I mean, if I don't, I will forget what I'm in there for. I mean, every single time. In fact, on my worst days, I have to check my own ID to see what my birthday is. Not a joke. But on the other hand, it's a good thing because I don't struggle with what you guys are struggling with, which is like this whole internal conflict over, can I make myself remember this? Because like a lot of people have this weirdness of like, I feel dumb if I have to write stuff down. I mean, I don't have that problem at all. I know that if I don't write everything down all the time, I will just forget it. Done. End of story. But if you do have that problem, you need to realize that the problem itself is frankly kind of stupid. Because, I mean, it's one of those weird classroom things. Like if you would not feel dumb, for instance, if you wrote down everything that has to do with your taxes. That would not make anybody here feel dumb. You'd be like, you know what, I'm organized, I'm on top of my game. That's not stupid thinking. That's smart thinking. So you just need to transfer that kind of thinking onto this game. Just document everything. Just do it. Don't make yourself remember stuff. Because you're Ron, then you can't remember stuff. There. That'll help. So meaning like there's no way my brain will not simultaneously hold this checkpoint and this goal. It cannot do it. Like I cannot keep this and also that in my head at the same time. Cannot do it. Not possible. So I just write them down, and then I don't have to. Not very hard, you just have to do it. And if you have any psychological barriers in the way of doing it, you overcome them. You're just like, you know what, nope, I need to write this stuff down. So, okay, let's talk about it. Okay, we can pick, yeah, mine doesn't. Mine does not hold 3 items. So, welcome to my world. Okay. And by the way, if you're trying to hold 3, that means you cannot also solve the problem, which would be the 4th item. Just don't do it. Don't make yourself remember things. Document everything. Like if you have trouble with quantifying that, here's what I mean. What I mean by write everything down, here's a test. If you came back to your scratch paper after a month, would you be able to pick up immediately where you left off? If the answer is no, you are not writing stuff down enough. There. So if you that's kind of, Tom, that's basically what I was saying, right? If you try to tax your working memory to the fullest. So notice if I write this stuff down and I write that down, if I come back to this next month, okay, it's been 30 days. I mean, I can still tell exactly what's going on. Like I know that I have to pick numbers that do this, and then I'm checking out this, and I'm checking out that, and I'm trying to make these two things happen. I mean, I could come back to this in like 5 years, and I would still know what was going on. So do that. That's a test. Because honestly, most people's scratch work is so bad that if they came back 10 minutes later, they would have no idea, not blessed clue number 1, what was going on. So this needs some work. You should work on it. You should have work where if you came back after a month, you would still understand it. All right. Let's pick cases. So again, your first case can be, all right, one way to make this clearly happen is to make z 0 again. So you can use your 1 and 1 and 0 again. So 1 plus 1 is greater than 0. That is true. So then 1 plus 1 is still greater than 0. Neato. Cool. Check off the box. Yeah, notice the other thing is that people don't want this to be the issue. I mean, the other thing that sounds obvious when I say it, but just make sure that you pay attention to it. If this is the issue, you need to, in capital letters, you need to be willing to study it. Because a lot of people are not. They're not willing to do that. Like, they just want to study math. And again, it's not rational. I mean, people would not have any problems studying how to document taxes better. But this is just, I feel dumb if I have to think about this. Well, don't feel dumb about being organized. I mean, just apply standards like this and think about it. Just, okay, if I came back in a month, maybe actually leave it for a month and then come back to it. And then if you don't understand it, just quantify what don't I understand and then fix it. So, I mean, my taxes are very involved because I have a lot of freelance work, but that's beside the point here. So, okay, this. What is our goal? Our goal is to keep this true, but make this false. Aha. There we go. Notice if you have all this stuff written down, you don't need to struggle to keep this in your head. So now we need to keep this true, but make this less than or equal to. What kind of numbers will do that? So 2 of you mentioned 2 different kinds of numbers earlier. Vic, maybe depending on what that means. Although, it sounds like 3, 4, and 5 or something like that. Those would be irrelevant here because this would be false. Wait, oh, maybe not. Rad 3, rad 4, rad 5. Maybe. All right, we'll try that one. First, let's dismiss the one that doesn't work. That's this one. not to make an example of anyone. I mean, if you don't understand why this is not a factor, then just plug a couple in and you'll see right away why they're not. So, because these are all even powers, all of them, they are all even. So positives and negatives don't matter at all. And if that's not clear, then again, the name of the game is do stuff and don't not do stuff. But when you plug negatives in, they will do precisely exactly the same thing that positives will in both statement 1 and statement 2. So, okay. So, all right. Okay. All right, this is kind of cool. Suvix numbers. So this is square rad. This is rad 3, rad 4, which is 2, and rad 5. So then if you square those, then 3 plus 4 is greater than 5. That works. And then this is 9 plus 16, and that's 25. Aha. All right, this is actually really cool. That does prove that it's not sufficient. On the other hand, I would not expect most people to come up with this, so we'll look at values that I can expect more people to come up with. I mean, this is actually brilliant. This is not anything that I ever would have thought of. But let me point out that Suvik, I bet you would not have thought of these numbers if all of this baseline stuff was not written down and in front of your face. And that's what gives you that freedom to think up cool stuff like this. Is that you don't simultaneously have to remember all this stuff, right? So there. So I mean, okay, that is amazingly brilliant. In fact, it's so amazingly brilliant that I don't want to have it as our only example because I wouldn't expect people to randomly come up with numbers like that. But those are very nice numbers, so they're cool. Jeff says, why can't you just use 115? Let's try that. Notice you have a checkpoint. All right, well, is 1 plus 1 greater than 25? Nope, does not count. Definitely nope, that makes sense. This is why we put a checkpoint in there that is on the paper and in front of your face. Does not qualify. Okay. What's another type of number that, because here's the deal, right? You guys need you need z squared to be less than this stuff, but you need the order to be reversed when you raise them to higher powers. I mean, what's a special weirdo kind of number that does that actually reverses its behavior when you raise it to powers? Yeah, let's try fractional numbers, right? So if we try something like, I don't know. I mean, let's just start by trying something like this. Like a half, maybe a half and a half and a half. I mean, this is clearly not going to work, but it's a starting point. Like, the point is that we're investigating. If we do that, then that's a fourth plus a fourth, and that's a fourth. So that works. But the problem is that a 16th plus a 16th is still greater than a 16th. So now what do we need? That's not what we want. How do we need to adjust these numbers? Like, what are we trying to get to happen here? Yeah, we should try to increase z, but not by too much, right? Because we need this to get bigger, because remember, that's the goal. So, and notice if you're staring at all this in the face, then you can figure it all out pretty quickly, right? We need this to be bigger, but not so big. Negatives don't have anything to do with statement 1. TF. Winkler because these are all even powers right now. So, like, negatives will not affect statement 1 in any way at all. If you, because this, right, this checkpoint is not affected by signs, and neither is this. Yeah, maybe you can't. All right, let's see where this goes, right? So we want to make this bigger, but not so big that it disrupts this. All right, that's pretty clean goal, right? But not so much bigger that this is affected. So let's make it bigger. We need this to be still under a half because that's a half. So, but let's make that really close to a half. Let's make it as big as we can. I mean, let's make it something like this. I don't know, 1/2, 1/2, and Z can be, that would be a square root of a half. Try making it a little bit bigger than a half, 2/3. So now we got a fourth, and we have 4/9. That's true. You can tell that 1/2 is more than 4/9. If you have to make common denominator, you can make one. This is 1/16 plus 1/16, and that's 1681. Notice there's a couple ways to do this. You can make this 80th. That's 5/80th plus 5/80th. So 10 over 80, 16 over 81. These don't technically have a common denominator, but it's pretty clear that the one on the left is smaller. Because 80 is almost the same thing as 81. And 16 is way, way, way bigger than 10. So we've got not sufficient again. Or you could use suffix numbers, or there's probably a bunch of other ways to do it. The point is just that you should do stuff and you should not do stuff. If you're using integers, PF Winkler, I don't know if you can really make this work with maybe. You probably can. You probably can do it with integers if you just mess around with them enough. All right, now what about both statements together? Notice all we're doing here is adding statement 2 into the mix. Do we need to do any extra work? We don't, because if you look at these, well, not that one, but at least the ones that did what we want. We just need to add statement 2 into the mix, but we know that 1 plus 1 is greater than 0, so this works for statement 2 as well. Yeah. And then we also know, I mean, if you look at this, a half plus a half is 1. So that works for statement 2. So both of them actually work for both statements. So almost by pure accident, we have settled the issue. So it's still not sufficient, and it's B. In fact, I do believe that every single set of values that satisfies statement 1 will also satisfy statement 2. I think that every single one will. I'm not entirely 100% positive of that, but I'm pretty close. Okay, so notice we had a lot of notes there along the way about thinking and not thinking and writing stuff down, but I mean, this is clearly a challenging problem. But the challenge is not where most people think it is. Because if you guys know that fractions are weirdos, that's kind of the only math that you have to know to do this thing. You just have to know that fractions are weird faces. You know, or that negatives are interesting things, or what have you. Beyond that, it's a matter of setting up goals, knowing what the heck you're trying to accomplish, what you're not trying to accomplish, and taking it from there. So cool. And then lots of nice lessons about solving problems and about life kind of across the board there. Okay, what about that? And again, just to help you guys out here, I'm going to make that device. It was that. Still not sufficient. Okay. Remember, the first thing that you should do with this animal here is to make our device. So yes, to translate yes and no, then ditch them forever. So 0 is halfway between R and S. And then a no means that 0 is not halfway. Between those 2 points. This is what a no means. And then you make columns. And then you go to town. Go for it. The other hint that I am compelled to give you here is that this statement is not written this way to be tricky. Or unnecessarily indirect. Keep that in mind. So no, there's a good reason for them to write the statement that way. And when you look at it, you should think about what that is. Yeah, that's the diagram from the original. It doesn't really matter because remember that lines are with arrowheads are infinite anyway. But there is no such thing as running past the end of the line. Okay, we should be wrapping this thing up pretty soon. If you don't have an answer to it, you should think very honestly about, am I still making definite progress toward a definite goal that I can definitely articulate? Another thing that'll help you here, by the way, like imagine that you are actually doing the audio part of a video solution as you do your work. Like as in you can actually explain why you are doing the steps as you do the steps. Because as soon as you stop being able to explain what you're doing and why you're doing it, you know what that means, right? That means you're done. That means it's time to stop doing what you're doing. Like if someone asks you why are you doing that, and you'd be like, then that's time to stop. I mean, no BS at all. You should never be doing any steps at all ever that you do not have a reason for. Also, you should know where this whole weirdo thing comes from. Because, I mean, I've talked about this in previous sessions too. But in real life, nobody has this problem. Like, nobody has this problem of doing random steps that have no purpose. You know, like if you're building a piece of furniture in real life, if you get lost, you don't just start nailing together pieces of wood and hope that you get furniture. I mean, you don't do that. It's just not how life works. But in these kinds of things, people do that all the time, and you have to understand where that comes from. And like where it comes from is this horrible, horrible, horrible thing that they give kids when they're growing up called partial credit. That's where all of this comes from. Like partial credit is the worst thing you could possibly do to school children. Like it teaches them that being honest and saying I don't know how to do this is the worst possible thing you can do. And it teaches them that doing stupid steps that have no purpose is better. So just keep in mind there's no partial credit on this exam, and in effect there's negative partial credit in the sense of lost time. But do not ever do steps that you cannot justify. Another way of thinking about it, stupid thought experiment, imagine that you had to pay like $5 every time you did a step. You know, imagine if you would keep doing the steps. Yeah. Okay. Let's talk about it. So, all right, notice this. I'm trying to be very direct with the hints here, but the statement is they're not doing this to be jerks, okay? And this does not mean this. Because if it meant that, you know what they would probably do? They'd probably just say it. That's what they'd say. I mean, or at least they would put it, I mean, at most, you'd see some light transformation of it. For example, R plus S equals 0. Yeah, but like they are not tricky. Really, they're not. So if you see this and you think this means R equals minus S, you should be like, nope, that's probably not what that means. And that's especially true in terms of visual things. Like what they're doing here is like think about why would they use words? So like why are they saying this in words? Because it can mean more than one thing. That's why. That's the reason. And there's no way to express both of those things symbolically, right? You can't. I mean, I guess you could. You could do it with symbols if you wrote it like this. Then you could actually have that. You could actually write this. But the point is they're not going to do that because this is way too mathy for this test. It would actually be T plus S because it's T minus negative S, Thomas. But they're not going to do that because that's too mathematically intense. And remember that even at the highest levels, the point is to not be mathematically intense. Yeah, that's still the point. The point is to not require tons of math skills, even at the highest levels. No, still a simple goal. Okay. I mean, this could mean more than one thing, right? It could mean if those distances are the same, because what the words say, basically T is just as far from R as it is from minus S. which could mean that r and minus s are actually the same point. Or it could mean that t is halfway between those points. Because then, it's just as far from each one. They're equidistant, right? So halfway between r and minus s. Okay. So in other words, let's draw these things. First, let's get rid of statement 1. Okay, is 0 halfway between r and s? Well, so we know that r is to the left of s, so we can actually draw pictures on our device. So that is r dash, let's see, that looks like, okay, r 0 s, like that. That's what we're trying to do there. And then that's anywhere else other than that. So can you get it to look like this? If s is to the right of 0, let's make a smaller copy of that picture. Okay. So that means that s is anywhere in this zone right here. 0 is anywhere here. So can you get 0 to be, well, so the question is, so 0 is anywhere in here. So can you get 0 to be at this halfway point? Well, sure you can, because that is in that zone. And can it be elsewhere? Well, sure it can. So statement 1 is not sufficient. All right, now statement 2, let's draw that. It could mean that r and minus s are the same. In that case, this point that is labeled r would also be labeled minus s. In that case, where is 0? If this point called r is also, yeah, right, because that's minus s and that's s, which means that 0 is going to be the exact halfway point. So in that case, that's going to be L zippo. So in this case, 0 is definitely halfway between r and s. But then it could also mean that t is halfway between r and the opposite of s. In that case, that means that t is the halfway point, which means that the opposite of s is actually here on the other side of t. Sorry, it's way over on the other side of t, because these distances from t have to be the same. So in other words, that distance has to equal that one. That's fine too. I mean, where is 0 in that case? It's going to be exactly halfway between which 2 points? Yeah, see, okay, notice these are not scale diagrams, so we don't necessarily know that it's actually to the right of t. But we don't care, because remember, the question is only whether it can be placed halfway between r and s. So the deal is that this is s and the opposite of s, and so we know that 0 is going to be wherever halfway between those is. I mean, theoretically, t could be really close to minus s here, because data efficiency diagrams are not drawn to scale. But we don't really care, because that's not the point, and it's not the goal. And if you're thinking about that, it probably means you forgot what the goal is. So notice in this case, 0 is most definitely not between halfway, because it's not between R and S at all. So it's definitely not halfway between them. So that case is not sufficient, again, because in that color we checked that one, and in that color we checked this one. All right, now what does statement 1 do? If you combine the statements. Yeah, if you combine the statements, then if you do that, then that gets rid of that second case. And it leaves you with only the first one. So this is sufficient. So C like cat. So let's see. This is if you have this. See, this is the kind of thing, people think this is a test where you have to study advanced math. Hardly. The stuff you have to study is stuff like this. I mean, you first learned this in like 7th or 6th or 5th grade. But it's still unclear for a lot of people because people are too busy thinking about more advanced things, quote unquote, like here. Don't pronounce this negative S. Don't call it that, because that's not what it is. Notice I have not been calling it that, because then you'll think that it has to be negative. Oops. This is pronounced the opposite of S. And it does not have to be negative any more than S does. I mean, for example, if S is -10, then what's S? Then what's the opposite of S? What is it? It's 10. Hey, cool. So then you would have on a number line, I mean, you would certainly have that, right? -10, 0, 10. So here you have your S, and here you have your opposite of S. And so that's how it works. So, I mean, and it might even be silly. So notice the issues might even be the way that you say words. Yep. The point is that whatever the issue is, be careful with flipping number lines because this is not flippable to the right of number. I mean, because then this would become the left of, and you can't flip statement 1. Because if statement 1 said left instead of right, then statement 1 would actually be sufficient. So be careful with flipping. I mean, if you're going to think about flipping, the problem is you're also going to have to flip everything else that has to flip along with it. That's probably much harder than just thinking about the original situation. Because, yeah, see, the problem with statement 2 is the other stuff doesn't move, right? You can flip that relationship, but the stuff that is in place on the number line is still in place. So be very careful with that. In general, if you're getting too tricky with your approaches, that's probably not a great thing. I mean, like if there's one point that I hope is super clear here, it's that like the problems at every level are like they really mean what they say and they say what they mean, and any like rephrasing you do should be relatively minor. The difficulty rating, we don't know and you don't care. Because, in fact, the fact that you have to ask this question proves that this question has no importance. There. The last thing about this is, the last comment that I want to make is something like this. I mean, this is a thing, this is a simple restriction that's clearly not sufficient by itself. I mean, again, clearly, there's like 35 of you guys and nobody picked A or D, right? What I'm going to give you an insight into here is the anatomy of this problem. Because what I mean in particular is if you know how these guys roll, you can guess this one in like 10 seconds. It's guessing. This is not infallible, and it doesn't take the place of doing the work. But this is some simple restriction that's not sufficient alone, and this is, well, a complicated-looking thing that clearly represents more than one case. Again, clearly is, I mean, if you think this automatically meant that R equals minus S, it means you don't really understand how the GMAT works. So that's a strong statement, but it's an important statement. Like, if you thought this meant, if you interpreted this as R equals minus S, then you don't really know how this test works. I mean, that's a very strong statement, but the point is when you see this, because again, the people who write this test, they are not jerks, they're not tricky, they don't do things in ways that are obscure just for the sake of being obscure. They don't ever do it, ever, ever, ever. So the point is, when you see this statement, you should be like, I know for sure this is not just a stupid way of writing R equals minus S. It's not, because they wouldn't write it that way if it was. So if they write this, you should think that it means that your first immediate thought should be they're writing it like this because it represents multiple things. And that's the way this test works. So if you see this kind of thing, like the answers to the problems that are like this, they are talking about distances. I don't know what moduli is, but they are talking about distances. If you see problems like this, oh, okay. Modulus is just another indirect way of talking about distance, though. So if you say that, you're still talking about distances. Problems like this are overwhelmingly C. Because if you think about it, that's kind of what they're doing with this. You know, because the point of when you see all this stuff, you should think, okay, this is multiple possibilities. And so the point of something like this, which by itself is clearly not enough to solve the problem, is that it knocks out a possibility. And that's what they're doing with that. Again, this is not 100%, but this is actually a very solid thing that you can guess if you get stuck behind the 8 ball in one of these problems. So look for it if you see this kind of anatomy to a problem, then you should think about that, whether it's that kind of situation. Okay, let's kill it. No, definitely not a C-trap. Oh, Lord, no. The point of C-traps is that they are like so easy that it's like second grade math, and that you ignore most of the stuff in the problem, neither of which is happening here at all. If you're thinking C-trap, I would suggest that you go back and watch the video about C-traps, because this problem does not come anywhere close to satisfying what a C-trap is. So check that out and make sure that you understand those ideas. Okay. But yeah, to see traps is super, super unbelievably easy, plus not using everything in the problem. Okay. I have absolutely no idea what that means. It's a joke, and apparently I'm not getting it. All right, let's kill it, guys. Thank you, and until next time. We do have a few more of these in the slides, so maybe we will keep this up. Maybe we'll continue with this topic for the next session. But gotta run. Thanks all for attending. Glad you enjoy them. And gonna kill the recording.